All right, guys. So for this lecture, we're going to take a little bit of a look at some of the accessory organs of the digestive system. So those would include all of those listed here. So things like the salivary glands that are on both sides of the mouth, underneath the tongue, and at the base of the tongue, your teeth, pancreas, liver, and then finally your gallbladder. So let's go ahead and kind of hop into this one and take a little bit of a look at these. So the first thing we're going to take a little bit of a look at are the basic salivary glands. They are responsible for producing the saliva in the mouth. Then there are a couple different sets of them. They're what are referred to as parotid glands. These are located anterior to the ear. So they are kind of right at the back of the kind of mouth, right at the base of the skull on either side. And then they have a duct that leads directly into the oral cavity. There are also ones that are called submandibular glands. Those are directly just below the mandible. You can kind of palpate those back on both sides. And then there's another one that's referred to as a sublingual, which is kind of underneath the base of the tongue. All right, and together, those produce most of our saliva for kind of getting that bolus of food prepared to be able to be swallowed and get into the stomach. In the cat, those glands are kind of superficial to a lot of the other structures underneath the chin here. So you can see the cat's been dissected away. It's been quite a bit of tissue actually removed. So there's a muscle that kind of sits across through here called your platysma. Actually goes from the chin all the way down to the sternum. So that's been removed. This is the masseter muscle that would go up and kind of attach into the skull to help you chew. So it kind of goes from the mandible up to the base of the skull. But this would be one of the parotid glands right here on the outside. Its duct, you can actually see it right here, leads into then the oral cavity to produce the saliva. All right. Basic functions here of saliva. It helps to kind of mix with some of the other fluids in the body to kind of produce and kind of break down this bolus of food. The main thing that happens in saliva is there's an enzyme called amylase, and that's one that is hugely important for digesting starch. You guys might remember, depending on the teacher you had for biology, you might have done a lab where they gave you part of a saltine cracker. All right. And when you put the saltine cracker in your mouth, it first tastes very savory, obviously. But over time, if you let that saltine cracker sit in your mouth, the amylase in your saliva will actually start to digest it and break it down into its monosaccharides, simple sugars. And when it does that, the cracker actually starts to become more sweet tasting. Most of us don't let it dissolve that well into our mouth to be able to tell that. But that was one lab that some of us do in bio to kind of show that basic process. All right. There's also other chemicals that can be dissolved in here. Some proteins start the basic process, as well as fats can start that process. But the main one here is sugars or starches. Okay. All right. Our next structures that we're going to take a little bit of a look at in the role of digestion are the teeth, and they play really only a role in mastication or chewing. So again, they're in there to kind of break this food down into smaller pieces, prepare that bolus so we can swallow it, get it to our stomach, so the stomach can kind of do its main job. But that's the main purpose of teeth. Humans, we have two sets of teeth, uppers and lowers. We also have two sets of teeth. Set that are referred to as deciduous, which are normally referred to as our baby teeth. All right. And there are about 20 teeth of a full-grown aged adult. So you can see kind of the difference between those primary teeth versus permanent teeth. Primary teeth obviously are much smaller, not near as sharp. And they really only range everywhere from the second molar up through the what's referred to as the incisors. All right. Same thing on the bottom, on the mandible here. They range anywhere, again, from that second molar up to the incisors in the front. All right. Permanent teeth, once those kind of push their way out and kind of leave, all right, these are what we would see again. You add one more set of molars. All right. And then there would be a fourth molar back here that would essentially be your wisdom teeth. But for most people, this is the set of teeth that they end up with. Okay. Over here on the next slide, you can see a little bit of the permanent teeth and kind of the replacement for those. All right, so replacement of deciduous teeth usually begins somewhere around age 6 and can go all the way up to age 12. I know that seems kind of crazy that all the way to age 12 kids can still lose teeth, but I will tell you, my daughter just turned 13 this last year, and all the way up until almost her 13th birthday, she was still losing a few of her kind of primary teeth. All right. As humans, adults, usually we have a set of 32 teeth. But a lot of times, some people don't keep those wisdom teeth, so they would be 4 short, all right, because of those wisdom teeth here at the back. There just isn't enough room in the mouth for those. Some people have it. Some people have enough space for them, but most people do not. And then there are also some people that are actually born today that will never have them, so they won't have to have them removed. Some of you might have already had yours removed. So usually around age 18, somewhere between 18 and 20 years old, is about the time that those wisdom teeth come in, and they tend to either have to be removed, or if you have enough space, you have them, or if you're lucky enough to be evolutionary along, then you don't have them. All right. This just shows you a little bit more of kind of when those kind of show up and kind of where they show up. So you've got your incisors. Those are the front teeth that are more kind of flat on the front. You have your canines, obviously on both sides. There's 2 sets, okay, that are kind of more pointed. You have what are referred to as premolars, so they're kind of a hybrid between the canines and molars. So they've got ridges on them as well as points. Then you have a couple different sets of molars, and then your third set of molars essentially are, again, your wisdom teeth. Again, you can see when those start to kind of show up. So incisors, permanent ones, show up somewhere between 7 to 8 years of age. Wisdom teeth, or sorry, canines show up about 8 to 9 years of age. Those premolars are anywhere from 11 all the way up to about 12 years of age. All right. Your first set of kind of permanent molars start to show up around 6 to 7 years old, and then 12 to 14. And then again, like I said, 17 to 25 is about when those wisdom teeth, those last set of molars kind of come in. Okay. All right. Next organ we're going to talk a little bit about then is the pancreas. So this is the one that's responsible for producing some more of these digestive enzymes to help us kind of break our food down. Most of those enzymes that are being produced by the pancreas are secreted into that first section of the small intestine, the duodenum or duodenum, however you want to kind of pronounce it there. All right. And then the main purpose of this really is to turn that food more alkaline. Remember, this just come out of the stomach. All right, so it's got a lot of hydrochloric acid in it, and we need to neutralize that. Otherwise, we could cause some damage to our small intestine. All right, so a lot of those enzymes are there really to kind of neutralize that acidic chyme that's coming out of the stomach. Other things that are being produced by the pancreas, we have both insulin and glucagon, and we talked a little bit about those in the hormone chapter. Remember, insulin helps to reduce blood sugar levels, and glucagon helps to increase blood sugar levels. So just depending on kind of what's going on there. Remember, insulin is being produced by the beta cells, glucagon is produced by the alpha cells. So that's the reason why sometimes people have an issue with, say, like type 1 diabetes. Those beta cells just aren't working the way that they should for them. Okay. All right, next organ then is the liver. So the liver's main function is to kind of do some detoxifying as well as break down some specific structures or specific kind of chemicals. All right, so its main function is to produce bile. And then other things it will do for us, it will help us break down both drugs as well as alcohol. And then any hormones left over in the system after the body is kind of used up with them are broken down here as well. The liver produces cholesterol, and then it plays a huge role in metabolism because of those different functions. It is our largest gland in the body. It's located kind of over on the right-hand side underneath your diaphragm. All right. You can kind of palpate it almost all the way along the bottom of your ribs, almost down to your floating ribs. Right. And then it does leak itself across the sternum over to the left side of the abdomen just a little bit, but not much. All right. There's 4 lobes to it. And then there is a little organ that's kind of trapped within inside of that called the gallbladder. And that simply is just the space where the liver stores its bile before the bile then is dumped into the small intestine. You can see a little bit of that kind of picture of what that looks like here on the cat. All right, so again, here's the liver for the cat. The cat's got a couple different lobes here as well. And then this little balloon-shaped structure is the gallbladder, and you can see this is the bile duct leading down into the small intestine right here. Stomach's right over here, so stomach's dumping into that small intestine. This would be the duodenum. And then that's where the gallbladder is dumping that bile into. Okay. Um, the liver, just to kind of give you some information, the liver is a lot different than most of our other organs, and you can kind of see that here. So the stomach and the cat is mostly empty at this point when we dissect, so it tends to be kind of flat. Whereas the liver, it's more of a dense organ. Kind of think the difference between like a stress ball, that would be more kind of like the stomach and everything else, and then a bouncy ball is kind of the way the liver feels. Because of that, specifically when we talk about injuries, the liver is one of those organs that can actually be what's called lacerated. If you take a blow to the liver, or there's a compact kind of injury that would kind of compress down on your ribs, the liver doesn't compress. So instead of that, it actually kind of breaks apart and kind of gets out of the way. It's almost kind of the consistency of like your standard pink eraser, right? So if you hit it hard enough or damage it bad enough, it'll actually split and make a laceration or a fissure down through the liver. Um, I will tell you, I've only seen a couple of those in athletic training. Both times they were football players. They both got hit with a helmet directly in contact with the liver. One of them was pretty serious. He had symptoms pretty quickly. The other one did not have very acute symptoms, just had some diffuse abdominal pain. And then towards the end of the game, he became more centralized kind of up on this portion of his liver. Sent him to the hospital. Obviously, they did a CT scan to kind of check real quick. And then they discovered the laceration in his liver, luckily, and then he did not have to have surgery. It heals on its own. Okay. All right. Other things that we have here, we talked a little bit about this before. So hepatic portal circulation. So this is kind of a unique circulation system between the liver as well as the digestive organs itself. So this is its own circulation that kind of goes in throughout both the small and large intestine as well as around the stomach. This is essentially done because the liver really needs a lot of those nutrients first, because it's one of the major metabolizing organs of our body. All right, so that's why it has its own system. The bile that's produced by the liver is produced in some of the cells that are there, and then it's simply just stored in the gallbladder. So you can remove your gallbladder and still process mostly fat. That's kind of what bile does for us. But you just don't do it as well, because you need a little bit of a storage of that to be able to produce enough to get it down into the small intestine. All right. Otherwise, you're just supplying what's coming directly out of the liver, and the liver might be producing at that point in time and might not. Most often when you eat a really fatty food, your small intestine notices that once the chyme's dumped into the small intestine, and then there is actually some muscular layers of this gallbladder that squeeze and then pump that bile into the small intestine. So really, bile itself is just a composition of a couple different things. There's some salts. There's a pigment called bilirubin that is essentially from the kind of the breakdown of hemoglobin. So bile tends to be kind of darker in color, almost kind of a dark brown, almost black. And then there are some cholesterol, some phospholipids, and obviously some electrolytes in there. Okay. Gallbladder itself, then, just give you some information about it. It's just simply a hollow sac that kind of sits in a portion of the liver. It's just simply there to store bile until it can be delivered through the cystic duct. All right. Again, it's introduced into the duodenum and usually in the presence of fatty food. So once the duodenum realizes that it has some fatty food within it, it'll actually send out a message to the liver to deliver this bile. One of the major problems that can happen with the gallbladder are gallstones. So because of its nature, of kind of the chemical nature of it, if I go back here, specifically these salts, and then some of these kind of phospholipids as well. But what they'll actually do is they will produce, sorry, I went too far. They will actually produce a stone. All right. Those stones will actually block this cystic duct or this bile duct. When that happens, if you eat something fatty, all right, then the gallbladder tries to contract and force more fluid into that, all right, or more bile down into that duct. That causes pain. All right. Normally, people notice it after they eat a fatty meal. If it goes on long enough, the person can actually have some pretty severe liver damage as well as damage to their pancreas because of the ducts going both directions. So if this becomes inflamed, all right, and then actually becomes infected, that infection can spill over into both the pancreas as well as the liver. All right. So if somebody has those kind of pains after eating a fatty meal and they notice it more often than not, they really should have that go checked out. And most often, the simple, easiest way to do is just remove it. The duct system is really, really tiny, and it's really hard to go in and try to remove some of those stones. Sometimes they can ultrasound it. They can actually send kind of it's similar to the ultrasound they use to kind of take a look at babies in the womb, but really what they're doing is taking a focalized sound wave and essentially trying to use that to break up those gallstones, right? And it can happen. Your kidneys can also produce stones, but they're much different than what's produced here in the gallbladder. Okay. All right, we're gonna go ahead and stop there.